Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Basicity and reactivity of amines toward acids depends on the availability of the lone pair on nitrogen. More electron-rich, more basic, amines react more readily with dilute HCl. Moving on to the next step. A. Benzylamine, PHCH2NH to the NH2 is on a sp3 carbon, separated from the ring by a CH2 group. The lone pair is not delocalized into the ring. pKa of conjugate acid (9.3). It is a fairly basic amine. B. Benzamide, PHCONH to the NH2 lone pair is delocalized into the carbonyl group, resonance, N lone pair, C is equal to O. This drastically reduces basicity. Benzamide is essentially non-basic, pKa 0, and barely reacts with dilute HCl. C. Structure shown is 4-aminopyperidine, or equivalently, 1,4-dihydro-4-aminopyridinium, a 6-membered ring with an endocyclic NH at N1 and an exocyclic is equal to NH at C4. This is an amidine-like or guanidine-like cyclic system. The NH at position 1 can be protonated, and protonation is stabilized by resonance with the is equal to NH at C4, similar to amidine resonance stabilization. The conjugate acid is stabilized by delocalization of positive charge over both nitrogen atoms. This makes it significantly more basic than a simple amine. The amidine-type nitrogen in such systems has pK 12-13, making it the most basic and hence most reactive toward dilute HCl. D. Aniline, PHNH to the NH2 lone pair is delocalized into the aromatic ring, reducing basicity, pK 4.6. Less basic than benzylamine. Moving on to the next step. Rank reactivity toward dilute HCl, proportional to basicity. Benzamide, B. Aniline, D. Benzylamine, A. 4-aminopyperidine amidine type, C. And for the final step. The cyclic amidine type structure in option C allows the lone pair on the ring nitrogen, N1, to be stabilized upon protonation by resonance with the imino is equal to NH, nitrogen at C4. This delocalization of the positive charge in the protonated form greatly stabilizes the conjugate acid, making the neutral amine exceptionally basic and therefore the most reactive toward dilute HCl. Why others fail? B. Fails because amide nitrogen lone pair is tied up by carbonyl resonance, very low basicity. D. Fails because aniline lone pair is delocalized into benzene ring, reduced basicity. A. Is reasonably basic but lacks the extra resonance stabilization of the protonated form that C possesses. Therefore, the correct answer is C. Therefore, the correct answer is option C.